Okay, so in this video, we're going to be demonstrating numerically that for a given average and standard deviation, that maximizing the entropy of a discretized probability distribution yields a normal distribution. So we're going to show a normal distribution graph. We're going to minimize the data that we get. And we can see in the last video, we already had made a function, or expression that has the entropy of a probability function. So we got the negative entropy from that. So we're gonna just import num_b as np, and then we're gonna do from plotly we're gonna make import subplots. So what make subplots? So we wanted to import numpy because we wanted to do calculations. We want to make some plots, and then from the sci-fi optimize, we want to import minimize. Okay, so that's going to allow us to use the minimize function that is within the database of the Python. Okay, so negative entropy, we're going to take the probability function. We want to return the np, the sum, and we derived this expression in our last video. So if you haven't watched our last video, go check it out. And it's the np.log of p. Yeah, I think that was the expression that we came up with. Yeah. And then we didn't put the negative sign because we wanted to get the maximum of it. So I just didn't add it in there, I guess. So what else we're going to need? Didn't I say we need 4 functions? So let's make 3 more. So we want the probability of the sum. We're going to take in the probability function. And then we're going to return np.sum p minus 1. The reason why we want 1 is because we want to optimize it as best as possible. And then we're going to do the average. Taking p, we're going to say the average is equal to np dot sum of p times grades. Okay. Oh, I know there's looking like an error right now. We'll come back to it. RT, so np dot sum. So right now we're gonna take the average of it, so we're square rooting it and we're summing up all the values, minusing the grades and the average. So it's gonna go through this function. Yeah, and then we're gonna multiply it by 2. And then we're gonna just give it a value of like -7. And then I see we have a problem here. So I think I did not define grades. Okay, let's give grades. We're gonna arrange it, and then we're gonna give it a value of grades. Well, we need to find what those grades are, right? So let's say we'll give grade 60 or 50. No, 60 is good. And then now we're going to need to make one more function that calculates the standard deviation. So we're just calculating the standard deviation in the form of writing it in a form of a function that takes in the value of the probability. Oh, this was not the average. I meant to say that was the standard deviation, and this was the average. Yeah. I don't know. I just rewrote it completely wrong. Yeah. So with this formula right here, this calculates a standard deviation by takes in a value of the probability, averages out and sums it all up the grades, and it returns the square root value of it minus d7. So the average is np dot sum p times grades. We'll say the average on the exam was a 30. That's very bad though. How can you get a 30? Okay, so now we need to do the probability. And you know what we're gonna need to do? We want to make it full. And we want the grades to be in a value of 0.1. And now we can finally use our probability distribution. And then we want to minimize it. That's why we imported minimize from earlier. Right? We're going to give it a callable, fun. We're going to say that's negative entropy. And we're going to say XO was equal to the PO that we just created. And we're going to give it bounds. We're going to get bounds from 0 to 1. Yeah, we're going to give it bounds to 0 to 1. And then now, oh yeah, we're going to multiply that by the grades. Now we're going to define some constraints. Equals, and then this, and I need to do the squiggly, and then I need to do type. We're going to give it a type. And we're going to say there's inequality and there's equality. We're going to give it equality. And then we're going to give it fun. We're going to get callable. And we're going to define the P sum. Okay. Now we're going to need to do this for all of the functions that we made. So I'm going to copy and paste it. Copy paste it 3 times. And then this one is average. And this one is standard deviation. Looks good. Now we're going to need to make the graph. So we're going to call that figure. We're going to make subplots. This will allow us to call the subplots within the Python mainframe. And then we're going to add bar. We're going to say the x is equal to the grades, and the y is equal to the probability distribution times x. And then as you can see, by creating these functions within this minimize function, we're able to get maximize the entropy of a discretized probability distribution and get a normal distribution, as you can see here. All right. Thank you for watching.